So in this video, I'll discuss the structure of organic compounds, the different functional groups, and the structures of biomolecules. Okay? So organic compounds are compounds that contain at least one CH bond or at least a recognizable functional group. So dito i-mention ko lang muna yung mga functional groups, tapos later ko na i-classify yung mga functional group classes. So dito magsusurvey lang muna tayo kung ang isang compound ay organic or not. Okay? So for the first example, we have formaldehyde. So yung formaldehyde, meron siyang aldehyde functional group and meron siyang dalawang CH bonds. So therefore, formaldehyde is organic. So yung acetic acid, meron siyang carboxylic acid functional group at tatlong CH bonds. So therefore, acetic acid is organic. Okay? So carbonate contains 3 CO bonds. So hindi natin siya pwedeng i-consider na carboxylic acid like yung acetic acid. Tapos wala rin siyang CH bonds. So therefore, carbonate is inorganic. So yung diamond naman, puro siya C single bond C bonds. Okay? And wala siyang CH bonds. So therefore, wala siyang recognizable functional groups. And yung ating diamond ay inorganic. Okay? Per classification. So yung ating ethene, meron siyang CH bonds and meron siyang recognizable functional group. That's an alkene. Okay? So ethene is organic. So yung graphite natin, puro siya C double bond C and C single bond C na alternating, pero wala siyang CH bonds. So we cannot consider graphite as an organic compound. So yung graphite natin ay inorganic. Although yung graphite natin can be derived from organic compounds. Okay? So oxalate contains this functional group and a CC bond. Wala siyang CH bonds, pero this can be considered as a carboxylic. Okay? So, therefore, oxalate can be considered as an organic compound kasi meron siyang recognizable na functional group. So, yung hydrocyanic acid, that's C triple bond N. Okay? Tapos, meron siyang CH bond. So, therefore, hydrocyanic acid is organic. Although yung CH bond na to ay acidic. Okay? So how do we write the structures of our organic compounds? So for example, we have here N-pentane. So we can write the molecular formula. Okay? So the molecular formula is the formula wherein you write the number of each atoms involved doon sa kanyang structure. So meron tayong 5 na carbon, so that's C5. Tapos 12 na hydrogens, so that's H12. Okay? So that's C5H12 for N-pentane. Pwede rin natin isulat yung condensed structural formula. So structural formula, makikita na natin or magkakaroon na tayo ng idea kung paano sila nakabond sa isa't isa. So we have here CH3, CH2, 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 CH3. So ibig sabihin dyan, yung mga carbons ay nakabond sila sa isa't isa. Okay? So yung mga hydrogens ay nakabond dun sa mga carbons. Kaya naka-incorporate yung mga hydrogens doon sa bawat isang carbon. So meron tayong total of 5 carbons there and 12 hydrogens. Okay? So if we write the complete Lewis structure of this compound, makikita natin to. Okay, so we are seeing various carbon-carbon bonds. Okay? Tapos meron tayong dalawang ends. Yung dalawang ends natin yung CH3. So makikita rin natin yun sa condensed formula. Tapos yung mga hydrogens ay nakabond sa mga carbons. Tapos lahat ng makikita nating carbons dyan ay single bonds lang. So ibig sabihin sp3 hybridized lahat ng carbon. Okay? So if we condense this formula, magkakaroon tayo ng condensed structural formula. Hindi na natin kailangan i-indicate yung mga carbon-hydrogen bonds. So that's CH3, CH2, 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 CH3. Okay? So halos similar lang sila, pero nag-include ako ng line to emphasize the carbon-carbon bond. Tapos for the skeletal formula, every corner of this structure is a carbon. Tapos yung mga hydrogens dyan ay implied. Anong ibig sabihin ng implied? Okay? So kapag implied, ibig sabihin, hindi natin siya kailangang ilagay, pero we have to be aware that they exist. Okay? So for example, yung isang carbon dito, nakakonect siya sa isang carbon, tapos automatically we should assume na meron pa siyang tatlong hydrogens dyan. Kasi an sp3 carbon should have 4 bonds around it. So yung ibang bonds ay hydrogens dapat. Okay? So let's clean this up first para ma-emphasize natin yung iba. So makikita natin yung mga hydrogens sa gitna. Okay? For example, or yung carbon sa gitna, makikita natin. For example, here, nakakonect siya sa dalawang carbons. Okay? So, ibig sabihin, meron na siyang dalawang hydrogens dito. So, a total of 4 bonds. Tapos, yung dalawang carbon-hydrogen bonds dyan ay implied na lang. So, dapat malaman nyo na yung carbon ay may 4 na bonds. So, capable siya ng 4 na bonds. So, kung nakakonect na siya sa, for example, dalawang bond or dalawang carbons, yung dalawa doon or yung the rest ng bonds ay dapat carbon-hydrogen bonds. Okay? So, dito rin, meron siyang dalawang implied carbon-hydrogen bonds. Dito rin, may dalawa siyang implied carbon-hydrogen bonds. Tapos, sa dulo, may tatlo siyang carbon-hydrogen bonds. Kasi isa lang yung kanyang carbon-carbon bond dito. So, meron tayong total of, okay, so ulitin natin, mag-clean up. So, meron tayong total of 5 carbons, kasi meron tayong 1, 2, 3, 4, 5 corners, tapos meron tayong 3, tapos 4, 5, 6, 7, 8, 9, 10, 11, 12 na hydrogen. So, C5H12 pa rin yung kanyang molecular formula. Okay? So, very convenient magsulat ng skeletal structure lalo na kapag malalaki ang iyong compound. So, organic chemists always employ the use of the skeletal or the line bond structural formula kapag malalaki na yung ating mga organic compounds na ini-illustrate. Okay? So here we have some examples. So for the first one, we have the acetic acid. So malalaman natin dun sa acetic acid na meron siyang dalawang carbons, apat na hydrogens, at dalawang oxygens from the molecular formula. So for the condensed formula, magkakaroon tayo ng idea na meron siyang CH3 group or the methyl group or a carbon connected to 3 hydrogens dun sa isang part. Tapos the rest is CO2H. Sa structural formula, magkakaroon tayo ng clearer picture dun sa structure ng COOH or the CO2H. Malalaman natin na yung hydrogen ay nakakonect dun sa oxygen ng COOH group. And we have here the CH3. Tapos malalaman din natin na yung isang oxygen ay naka-double bond dun sa carbon. Okay? So for the skeletal structure, we have here the OH group. Tapos yung carbon na to, since apat na yung connections niya, so wala na siyang implied hydrogen. Okay? However, this one is connected to only one carbon. So ibig sabihin meron siyang tatlong implied carbon-hydrogen bonds. Okay? So for the next one, we have ethylamine. So malalaman natin na siya ay C2H7N. So dalawang carbons, 7 hydrogens, at isang nitrogen. Tapos sa condensed formula, malalaman natin na meron siyang CH3 group, CH2 group, and NH2 group. So segregated na lahat ng hydrogens. Yung tatlo ay nakakabit sa C na ito, yung dalawa ay sa second carbon, yung the rest ng hydrogens ay nakakonect dun sa nitrogen. So for a clearer picture, makikita natin dun sa structural formula na CH3, CH2, and NH2. So meron siyang carbon-carbon bond and a carbon-nitrogen bond. Tapos sa skeletal structure, makikita natin na meron siyang NH2 group. So yung dalawang hydrogen ay nakakonect dun sa nitrogen. Since yung carbon na to ay nakakonect sa isang nitrogen at isang carbon, meron siya dapat dalawang implied carbon-hydrogen bonds. Yung dulong carbon na to ay may tatlong implied carbon-hydrogen bonds kasi sa isang carbon lang siya nakakabit based on the skeletal structure. Okay? So next we have the isobutane. So the isobutane is C4H10. Meron siyang 4 na carbons at 10 hydrogens. Tapos malalaman natin sa condensed formula na meron siyang dalawang CH3 group and may isa siyang CH group at isang CH3 group ulit. Okay? So for a clearer picture, makikita natin dun sa structural formula na yung dalawang CH3 group ay nakakabit dun sa isang CH group. Okay? Tapos yung isang CH group ay nakakabit dun sa isa pang CH3. Okay? So sa skeletal structure, makikita natin na meron siyang tatlong CH3. So yung tatlong CH3 na yan, may tigta-tatlong implied carbon-hydrogen bonds. Tapos yung carbon dito, since sa tatlong carbon lang siya nakakabit, meron pa siyang isa pang implied carbon-hydrogen bond. Okay? So implied yung mga carbon-hydrogen bonds kapag sa skeletal structure. Okay? Tandaan nyo yan. So next is cyclohexane. So cyclohexane has a formula of C6H12, 6 na carbon at 12 hydrogen. So yung kanyang condensed formula is CH26, puro CH2 lang yung kanyang groups, okay? Wala siyang CH3 or wala siyang CH. So ano kayang implication nito sa structural formula? So ring structure siya na puro CH2 groups connected to each other, okay? So malalaman natin na bawat isang carbon or CH2 groups dito ay nakakonect sa dalawang CH2 groups. So ibig sabihin, we can write it like this. So each CH2 group has 2 implied carbon hydrogen bonds. Okay? So may tigda-dalawa pa silang CH bonds. Okay? So finally, we have benzene. So benzene is C6H6, 6 carbons and 6 hydrogens. So we have this condensed structural formula. So we have 6 CH groups. So ang manifestation nito sa structure ay ganito. Okay? So yung mga CH groups ay connected to each other through alternating single and double bonds. Pero malalaman natin na sp2 hybridized lahat ng CH groups na yan because they can perform resonance with each other. Okay? So yung mga double bonds pwedeng mag-transfer dun sa mga single bonds. Tapos same benzene structure pa din. And same pa rin yung mga formal charges ng mga CH groups dyan. Okay? So if you convert it to skeletal structure, meron tayong ganitong ring structure na may alternating single and double bonds. And bawat isang carbon dyan ay may tigi-isang implied carbon-hydrogen bonds. Okay? So how do we classify organic compounds? So we use the so-called functional group. Okay? So functional group is a part of the organic compound that governs its overall property and reactivity. So kapag meron tayong dalawang compounds and they have the same functional group, pwede nating sabihin na they will have similar properties and reactivity. Kasi yung functional group na yun, yung nag-govern dun sa overall properties ng dalawang compound. Okay? So what are the different functional groups? Punta muna tayo dun sa walang functional groups or yung mga backbone structures ng ating organic compounds. Okay? So they are called hydrocarbons. So not all hydrocarbons are non-reactive. Yung may mga hydrocarbons lang talaga na inert enough, okay, not to participate in typical chemical reactions. Okay? So yun na yung mga alkanes. Okay? Alkanes are carbons or hydrocarbons that only contain sp3 hybridized carbons. So by the way, meron tayong dalawang klase ng hydrocarbons. Okay? Yung R ay aliphatic and yung AR, capital A, is aromatic. So yung distinction ng dalawang ito ay didiscuss natin kapag nasa organic chemistry na tayo. Okay? Kasi yung aromaticity is a concept that is based on the conjugation of the pi electrons. So meron tayong mga criteria for aromaticity. So pwede ko siyang i-discuss in light detail mamaya. Okay? Pero yung actual distinction yan, mas deep yung understanding natin kapag sa organic chemistry. Okay? So let's go back to alkanes. So alkanes are hydrocarbons that contain only sp3 hybridized carbons. So for example, we have this is cyclopentane. So lahat ng carbon na yan ay sp3 hybridized. So bawat isang carbon dyan ay dapat na merong 2 implied carbon-hydrogen bonds. So may tiga-dalawa silang carbon-hydrogen bonds na implied kasi skeletal structure yan. Okay? So that's cyclopentane. That is a cyclic alkane. So kapag ka naman acyclic alkane, okay, or chain alkane, makikita natin na meron tayong example dito. This is 2-methylbutane. Okay? So, this is a carbon that has 2 or 3 implied carbon-hydrogen bonds. Meron siyang dalawa sa part na to. Isa lang yung carbon na to. Tapos, yung dalawang ito ay may tig-tatlong implied carbon-hydrogen bonds. Okay? The next type of hydrocarbon is alkenes. Okay? So, alkenes are hydrocarbons that contain at least one double bond. So, ibig sabihin, meron siyang dalawang sp2 hybridized carbons na bonded sa isa't isa. So, isang sigma bond and isang pi bond yun. Kaya siya double bond. Okay? So, meron tayong dalawang types based on the position of the double bond. Meron tayong terminal, ibig sabihin nasa dulo na siya ng inyong chain. So, ibig sabihin meron tayong dalawang implied carbon-hydrogen bonds dyan sa isang sp2 hybridized carbon. Tapos meron tayong isa doon sa kabilang sp2 hybridized carbon. Kapag internal naman, nasa gitna siya ng inyong chain. Okay? So, may tig-isa silang carbon-hydrogen bonds na implied dyan sa structure. Okay? Pwede din natin silang i-classify kung sila ay alkene, diene, or triene, depende dun sa number ng kanilang double bonds. So, i-emphasize ko lang yung dienes. So, dienes are alkenes with more than one or at exactly 2 double bonds in the structure. So, meron tayong dalawang types ng diene. So, meron tayong isolated. So, ibig sabihin kapag isolated dienes, hindi nag-interact through resonance yung iyong mga double bonds kasi separated sila by an sp3 hybridized carbon. Okay? Kapag naman conjugated yung dienes, yung mga double bonds mo ay adjacent. So, ibig sabihin yung mga sp2 hybridized carbons mo dyan ay adjacent sa isa't isa. So, ibig sabihin nakakapag-interact yung mga pi systems na yan or yung mga pi bonds na yan through resonance. So, ibig sabihin yung mga pi electrons dyan nakakapag-travel all throughout the sp2 orbitals ng inyong mga carbons. Okay? So, for the next type of hydrocarbon, we have the alkynes. So, alkynes contain at least one triple bond. Okay? So, ibig sabihin kapag meron kang triple bond, meron kang dalawang sp hybridized carbons na nagbabond sa isa't isa. So, ibig sabihin, isang sigma bond at dalawang pi bonds yun doon sa triple bond. So, para lang din siyang alkenes, meron tayong internal at terminal alkyne. So, sa terminal alkyne, meron tayong hydrogen-carbon bond there. Pero this time, in-emphasize ko na siya. So, the carbon-hydrogen bond there is emphasized, hindi na siya implied. Kasi, this hydrogen is acidic. So, kung gusto nyo i-emphasize yung reactive na hydrogen, pwede nyo naman siyang i-indicate dun sa inyong skeletal structure. Okay? As long as involved siya sa, or meron siyang contribution dun sa magiging properties ng inyong compound. Okay? Kapag internal naman, wala siyang implied carbon-hydrogen bonds kasi connected na siya by a triple bond tapos yung isang sigma bond o yung natitirang sigma bond ay nakakonect sa isa pang carbon. So, total of 4 bonds na siya, wala na siyang room for a carbon-hydrogen bond. Okay? So then we have the aromatic compounds. Okay? So tatlo lang kailangan natin tandaan kapag aromatic compounds. It should be a ring, the pi systems should be conjugated, and there should be 4n plus 2 pi electrons where n is an integer. So tignan natin yung benzene. So benzene is a ring, so that's number 1, check. Okay? Then bilangin natin yung pi electrons. 2, 4, 6. So 4n plus 2 is equal to 6. So makikita naman natin na conjugated siya. Okay, kasi adjacent lahat ng sp2 hybridized carbons niya doon sa ring. So, check na natin si 4n plus equals 6. So, since n is equal to 1, okay, satisfied yung n is an integer. So, therefore, benzene is aromatic. Okay? So, tignan naman natin si naphthalene. So, naphthalene has 2 rings. Okay? Tapos, tignan natin yung bawat isang ring. So, yung bawat isang ring ay may 2, 4, 6 pi electrons. Tapos, yung isa pang ring dito ay may 2, 4, 6 pi electrons din. So, sinishare nung dalawang ring systems na to yung pi electrons na nasa gitna. Okay? So, ibig sabihin, n equals 1 for both rings. So, ibig sabihin, naphthalene is also aromatic. So, finally, we have the cyclopentadienyl anion. So, makikita nyo na meron siyang lone pair dito. This lone pair participates in the pi bonding. Kasi pwede mong isulat yung resonance form niya na dito naman yung magkakaroon ng double bond at sa ibang area naman magkakaroon ng lone pair. Okay? So, same lang din yung magiging formal charge ng anion na yon dahil pare-pareho lang naman dyan yung kanilang mga carbons. Okay? So, since conjugated yung pi systems, tapos we have a total of 6 pi electrons. So, 4n plus 2 is equal to 6. Okay? N equals 1. So therefore, cyclopentadienyl anion is also an aromatic compound. So balik tayo dito sa naphthalene. Sa naphthalene, ang bilang natin ng pi electrons ay per ring system. Hindi natin pwedeng bilangin yung kabuuan. Okay? So dapat ang bilang natin ng electrons ay sa bawat isang ring na part ng structure. Okay? So for sp3 carbons, we have a classification on the type of the carbon based dun sa kung ilan yung other carbons na nakakabit sa kanya. So kapag primary carbon, that specific carbon is connected to only one other carbon. So yung primary carbon ay nakakonect lang sa isang carbon. The rest are carbon-hydrogen bonds. Okay? Or the rest are non-carbon-carbon bonds. Hindi sila carbon-carbon bond. Isang carbon lang nakakabit yung iyong primary carbon. Kapag secondary naman, connected to 2 other carbons. Okay? Kapag tertiary, 3 other carbons. Kapag quaternary, 4 other carbons. So makikita natin dito sa example na yung mga green, okay, they are all primary carbons kasi sa isang other carbon lang sila nakakonect. Yung mga sky blue na to, those are secondary carbons kasi nakakonect sila sa dalawang other carbons. Okay? So, secondary din to kasi nakakonect siya sa dalawang other carbons. Yung yellow, makikita natin na isa siyang tertiary carbon kasi nakakonect siya sa tatlong carbons. The violet here is a quaternary carbon kasi nakakonect siya sa 4 na carbons. Okay? So now let's proceed to organic compounds with heteroatoms. So, meron tayong mga heteroatoms like halides, nitrogen, oxygen, phosphorus, and sulfur. So, pag sinabi kasing heteroatoms, sila yung mga atoms na hindi carbon at hindi rin hydrogen. So, itong halides na to, yung X kasi yung general term, pwede siyang fluorine, chlorine, bromine, or iodine. X is the general notation for halides. Okay? So, kapag metals naman, yung covalently bonded sa mga organic compound groups, ang tawag doon ay organometallic. Okay? So, organometallic kapag covalently bonded yung metals do sa organic compound o sa mga carbon compounds na kinoconsider nating organic. Kapag ionic bonding, hindi siya tinatawag na organometallic. Okay? Kailangan ang criteria sa organometallic covalent bonding. Okay? So, for halides, we have, of course, the alkyl halides. So, ang general notation ay yung alkyl group, yung R, tapos covalently bonded siya sa halide. So, meron tayong tatlong klase ng alkyl halides. So, meron tayong primary alkyl halide. Ibig sabihin yung inyong halide ay connected sa primary carbon. So, kapag primary carbon, again, nakakonect lang siya sa isang other carbon. So, makikita nyo na yung bromine ay nakakonect dun sa carbon na nakakonect sa iisang carbon lang. Okay, ganun din dito sa compound na ito. So, this is 1-chloropropane. This is 1-bromo, 2-methyl propane. Okay? So, those are primary alkyl halides. So, kapag secondary alkyl halides naman, yung inyong halide ay nakakonect sa secondary carbon. So, makikita nyo yung carbon na to nakakonect sa 2 other carbons aside from the bromine. Ganon din dito sa chloropropane or sa 2-chloropropane. So, makikita nyo yung chlorine ay nakakonect sa carbon na nakakonect sa dalawa pang other carbons. So, kapag tertiary alkyl halide naman, yung inyong alkyl halide or yung inyong halide ay nakakonect sa tertiary carbon. So, makikita nyo na itong carbon na to ay nakakonect sa 3 pang other carbons aside from the bromine. Ganon din yung case dito. Okay? So, ito yung carbon na nakakonect sa carbon na ito, at ito. So, 3 carbon siya aside from the chlorine. So, wala tayong quaternary alkyl halide kasi yung carbon ay nakakonect na sa 4 na magkakaibang carbon or sa 4 na other carbons. Okay? So, hindi na po pwedeng mag-accommodate ng isa pang halide kasi magiging 5 yung bonding ng ating carbon dot. So, hindi allowed ang more than 4 bonding sa carbon na sp3. Okay? So, now let's proceed to alkylamines. So, ang ibig sabihin ng alkylamines or amines, okay? Yan, pwede nating tawaging amines. Sila yung mga organic compounds na may nitrogen. So, meron tayong 3 klase ng alkylamines. So, primary amine, secondary amine, and tertiary amine. Pero, ang tinitingnan na natin dito ay hindi na yung carbon na kinakabitan ng ating nitrogen. Ang tinitingnan na natin dito yung mismong nitrogen atom. So, kapag sa isang carbon lang nakakonect yung iyong nitrogen, primary amine siya. Kapag yung nitrogen mo ay nakakonect sa 2 carbon, secondary amine. Kapag sa 3 carbon nakakonect yung inyong nitrogen, tertiary amine. So, magkaiba siya dito sa inyong alkyl halide kasi ang tinitingnan nyo sa alkyl halide ay yung carbon na kinakabitan ng inyong halide. Dito, ang tinitingnan nyo mismo ay yung nitrogen. Okay? So, magkaiba, again, ang classification or yung perspective kapag sa amines at sa alkyl halides. Okay? So, meron din tayong quaternary ammonium ion. Kasi kapag kaapat na yung kinakabitan ng nitrogen or sa apat na carbon na siya nakakabit, nagiging positive na yung kanyang formal charge. So, nagiging ammonium ion na siya imbis na amine. Okay? So now let's proceed to oxygen-containing organic compounds. So mag-start tayo sa alcohols and phenols. So makikita nyo kapag alcohol, alkyl group na may hydroxide or OH group. Okay? Kapag phenols naman, yung inyong OH group ay directly nakakonect sa inyong benzene ring. Okay? So, classify natin yung mga alcohols. So kapag primary alcohol, ibig sabihin yung OH group nyo ay nakakabit sa primary carbon. Yung carbon na yan ay nakakabit sa iisang carbon lang din. Okay? Kapag secondary alcohol, yung alcohol nyo ay nakakonect sa secondary carbon. So, yung carbon nyo nakakonect sa dalawang other carbons aside from the OH. Kapag tertiary alcohol, yung inyong hydroxide group ay nakakonect sa tertiary carbon. So, makikita nyo nakakonect yung carbon na to sa tatlong other carbons. Okay? So, that's for alcohol. Kapag phenol naman, ang tawag sa kanya ay aryl alcohol din. Pero mas madalas siyang tinatawag na phenol. Okay? So, ito yung phenol. Dapat yung OH ay directly nakakonect sa ring. Magkaiba siya sa benzyl alcohol. So, pag benzyl alcohol, yan. This is alcohol. This is not a phenol. Kasi, nakakonect siya sa alkyl carbon. Not on the carbon dun sa ring. Okay? So now, let's proceed to carbonyl compounds. So kapag carbonyl compounds, makikita ka ng C double bond O, tapos the rest are either carbon-hydrogen or carbon-carbon bonds lang. Wala nang ibang heteroatoms. Okay? So kapag may carbon-hydrogen bond dun sa carbonyl carbon, ito yung carbonyl carbon, okay? Yung carbon na naka-double bond sa oxygen. So that's carbonyl carbon. Okay? So kapag merong carbon-hydrogen bond sa carbonyl carbon, meron tayong aldehyde. Okay? Kapag puro carbon-carbon bonds, yung other bonds ng carbonyl carbon nyo, that's a ketone. Okay? So this is again na carbonyl carbon, tapos naka-connect siya sa dalawa pang carbons. So that's ketone. Kapag yung isa ay CH bond, that's an aldehyde. Okay? So now let's proceed to ethers. So kapag ethers naman, yung oxygen mo ay nakakabit sa dalawang carbon ng inyong dalawang alkyl groups. Okay? So meron tayong types ng ether, meron tayong symmetric ether. So ibig sabihin kapag symmetric, pareho lang yung dalawang R na yan. Okay? Identical yung dalawang groups. Kapag asymmetric ether, magkaiba yung structures ng magkabilang groups. Okay? So kapag cyclic ether, yung oxygen ay member ng isang ring ng inyong compound. So may ring siya, tapos yung isang member ay oxygen. So ether siya, pero cyclic. Okay? Epoxide is the smallest possible cyclic ether. Pero minsan kino-consider siya as a separate functional group kasi mas reactive ang epoxide kaysa sa ether. So you can consider an epoxide as a separate functional group. Okay? So brown ethers, makikita nyo maraming oxygen-carbon bonds, okay? And nagpo-form sila ng ring. Okay? So now let's proceed to acyl compounds. So acyl compounds have a general structure. So ang general structure nila ay ganito. Okay? Tapos, ganyan. So, meron tayong tinatawag na acyl group. So, the acyl group is the C double bond O, tapos yung isang bond ay nasa alkyl group or aryl group. So, this is acyl. Okay? This is the other group. Ito yung gagamitin natin para ma-classify yung ating acyl compound. Okay? If that group is OH, that's a carboxylic acid. And this is called the carboxyl group. Okay? So, yung part na ito, iyan yung acyl group. Pero yung part na to, yung C double bond OOH, that's the carboxyl group. Okay? So that's COOH because that COOH is the carboxyl group. Pag ester naman, OR. Okay? OR. The R is the alkyl group. Kapag naman lactone, ester siya pero cyclic yung compound nyo. Okay? So that's a cyclic ester. Kapag amide, NH2, nakakabit yung iyong acyl group. Pero pwede ring NR2, okay? Kapag may substitutions yung inyong nitrogen. Hindi lang siya necessarily H2. Okay? Pwede ring mga carbons yung nakakabit yan sa nitrogen mo. Kapag cyclic yung inyong amide, that's a lactam. Okay? So, cyclic, lactam siya. So, acyl chloride, okay? Kapag chloride, or pwede ring acyl halide. Okay? Kapag generalized, or X yung nakalagay dyan. So, that's RCOX. Okay? Ito again, yung acyl group, that's the chloride. Okay? Kapag naman carboxyl group yung nakalagay, that's an acid anhydride. So, ito yung inyong acyl group. Okay? Ito yung inyong carboxyl group. Okay? So, kapag yung acyl ay nakakabit sa carboxyl, that's an acid anhydride. Nitriles look like this. Pero, kinoconsider din silang acyl compound. Kasi kapag hinhydrolyze mo to or kapag nilagay mo ng water, nagkakaroon siya ng amide or nagko-convert siya sa amide. Okay? So nitrile is also considered an carboxylic acid derivative or an acyl compound, even though it doesn't look like one. Okay? So finally, we have the organosulfur compounds. So for the first one, we have the thiol. So imagine nyo yung thiol para siyang alcohol, pero instead of O, we have S. Okay? So that's RSH. Okay? So yung R ay alkyl group. So kapag sulfide naman, imbes na oxygen, tulad dun sa ethers, sulfur siya. So meron siyang dalawang connected na alkyl groups. Okay? So kapag sulfonic acid, meron kang dalawang double bond O, tapos meron kang OH group. So that's a sulfonic acid. Tapos meron siya, of course, na isang alkyl group. Okay? Kapag dalawa namang alkyl groups, tapos dalawang double bond O, we have a sulfone. So that's for the organosulfur compounds. So here we have some examples. So ang gagawin daw natin, i-identify natin yung functional groups, tapos i-determine natin yung bonds present sa mga boxed regions. Okay? So for aspartame, let's identify some functional groups. So meron tayong carboxylic acid, okay? And then meron tayong amine, and then we have an amide, and then an ester, okay? And then we have the aromatic compound. So this is carboxylic acid, and then this is amine, and then amide, and then ester. Okay? And then this is an aromatic ring. Aromatic group. Okay, lagyan lang natin. Ayan. So those are the functional groups present. So ano naman yung mga bonds present sa mga boxed regions? So unahin natin to. So we have a sigma, okay? Tapos yung ating carbon ay sp3c, okay? Ito yung carbon, tapos ito yung nitrogen. So yung nitrogen natin ay sp3 nitrogen din. Okay? That's the bonding in that boxed region. Dito naman, meron tayong sigma ng sp2 na carbon at sp2 na oxygen. So both oxygen and carbon are sp2 hybridized dito. Tapos, syempre, since sp2 siya, meron tayong pi. Okay? 2p ng carbon and then 2p ng oxygen. Okay? So finally, we have here this box. Okay? So meron tayong sigma ng sp2 ng carbon at sp2 ng isa pang carbon, and then we have the pi ng 2p ng carbon sa 2p ng other carbon. So those are the bonding dun sa mga boxed regions. Okay? So now, i-identify naman natin yung mga functional groups sa glutathione. So tingnan muna natin dito, meron tayong carboxylic acid. Okay? And then we have here the amine. Okay, so emphasize natin yung kasama dapat yung carbon. Okay? Ayan. And then we have the amide. And then we have the thiol. And then we have another amide. Okay? Amide din siya. And then we have another carboxylic acid. Okay? So, after nyan, tingnan natin yung mga boxed regions. Okay? So, yung bonding dito ay sigma ng sp2 ng carbon tapos sp2 ng or sp3 ng oxygen. So this oxygen is sp3 hybridized kasi yung electron pair geometry niya ay tetrahedral, while this one is sp2 hybridized kasi siya ay trigonal planar. Okay? So dito naman, sp3 pareho yung sulfur at carbon. So that's a sigma sp3 ng sulfur, sp3 ng carbon. Okay? That's a sigma bonding between the sulfur and carbon. Tapos dito, meron tayong sigma ng sp3 ng nitrogen at sp2 ng carbon. Kasi nakakonect siya sa sp2 carbon. Okay? Pero sigma bond lang siya. Dito yung may pi bond. Okay? So that's for the bonding and the functional groups of glutathione. Okay? So now let's proceed to paracetamol. So makikita natin na yung paracetamol ay may phenol and meron siyang amide. Okay? So yun yung mga functional groups niya. Let's proceed to the bonding. So sa box region na to, nakakonect through sigma bond yung sp3 ng ating nitrogen at yung sp2 ng ating carbon kasi this is sp2 hybridized. Okay? Dito naman sa phenol, this bond, okay? That's a sigma bond between an sp2 hybridized carbon and an sp3 hybridized oxygen. So mapapansin niyo yung oxygen dito, dapat meron pa siyang lone pair. So magiging electron pair geometry niya dyan ay tetrahedral. Okay? So let's proceed to aspirin naman. So sa aspirin we have a carboxylic acid and an ester. Okay? So that's an ester. So tingnan natin yung mga bonding. So this one, okay, that's an sp3 hybridized oxygen connected to an sp2 hybridized carbon. Tapos that's sigma bond. Dito naman, okay, that's an sp3 2 hybridized carbon connected to an sp3 hybridized oxygen. Tapos that's a sigma bond. Tapos dito, okay, dito sa box region na to, okay, that's an sp3 hybridized carbon connected to an sp2 hybridized carbon, and that is a sigma bond. Okay, so now let's proceed to the biomolecules. So biomolecules are large organic compounds that exist as functional or structural units in biological systems. So meron silang mga recurring patterns of structure na makikita natin sa mga biological systems and processes. Like for example, makikita natin yung mga amino acids sa enzymes, yung mga lipids sa mga hormones, and yung carbohydrates sa mga cell walls ng plants. Okay? Tapos yung nucleic acids, of course, makikita natin sila sa mga DNA or RNA na part ng ating genetic code. Okay? So there are four major classes of biomolecules. So for the first one, carbohydrates. So what are carbohydrates? They are polyhydroxylated aldehydes and ketones. So ibig sabihin ng polyhydroxylated, marami silang OH group, aldehydes and ketones din sila. Okay? So classification based on the number of carbons, we have pentoses. So kapag pentose, 5 carbon atoms. Kapag hexose, 6 carbon atoms. Okay? So examples of pentoses, we have ribose. Ito yung sugar unit dun sa ating RNA, yung ribonucleic acid. And we have the 2' deoxyribose or just the deoxyribose. So ang pinagkaiba ng ribose at deoxyribose, ito ay H, wala siyang oxygen, kaya sa deoxyribose. Ito ay may oxygen, kaya siya ribose. Okay? So for the hexoses, we have glucose. Okay? So this is the ring structure of glucose. And we have the galactose. Okay? So ang pinagkaiba ng glucose at galactose ay yung kanilang orientation lang. With respect to the three-dimensional space. Magkakapareho sila ng structure, magkakaiba lang sila ng mga orientations ng mga hydroxyl groups. So for the pentoses, makikita natin na meron silang furanose, okay? Kasi nagpo-form sila ng 5-membered rings, yung ribose at deoxyribose. So for this hexoses, pyranose naman, kasi nagpo-form sila ng 6-membered ring structures. So yung furan, or yung the furanose structure, yan yung 5-membered ring. Kapag ka pyranose, ito yung 6-membered ring. So, yung 5-membered ring may oxygen, yung 6-membered ring may oxygen din. So, this is furan, this is pyran. Okay? So, we can also classify carbohydrates based on the number of their subunits. Okay? So, yung simplest form ng carbohydrate is called the monosaccharide. So, yung monosaccharide natin, pwede siyang pentose or 5-carbon sugar, pwede rin siyang hexose or 6-carbon sugar. So, example natin dito, yung glucose, it's a hexose sugar, tapos naka-pyranose na form. So, ito siya. So, 6-membered kasi, or 6 carbon. 1, 2, 3, 4, 5, 6. Okay? So, this glucose is considered one sugar unit. So, isa siyang monomer or monosaccharide. Okay? So, for a disaccharide, meron tayong 2 sugar units. So, makikita natin dito sa example, this is sucrose, na meron tayong isang glucose. Okay? So, this is a hexose sugar. 1, 2, 3, 4, 5, 6. Tapos, meron tayong another hexose sugar. 1, 2, 3, 4, 5, 6. Ito naman yung fructose. Okay, kaya ang tawag sa kanya ay glucopyranosyl kasi this is a pyran. Fructofuranoside kasi this is a furan structure. So yung inyong pentose pwede ring or yung hexose nyo pala, pwede rin siyang mag-form ng furan structure. Okay, so ang example natin dyan ay yung fructose. So yung sucrose or yung molecule ng sucrose ay made up of glucose and fructose monosaccharides. Tapos, yung dalawang yun ay connected through the glycosidic bond. Okay? So, that is a glycosidic bond. So, ito yung bond ng OH kanina ng fructose, tapos ito naman yung OH kanina ng inyong glucose. So, nag-form sila ng parang ether. Okay? So, ang tawag dyan ay glycosidic linkage or glycosidic bond. Okay? So, then we have the oligosaccharide. So, kapag oligosaccharide, we have 3 to 10 sugar units. So, for example, we have here the raffinose. Meron tayong tatlong individual sugar units connected by 2 glycosidic bonds. Okay? So, kapag polysaccharides naman, we have more than 10 sugar units. So, for example, we have cellulose. So, yung cellulose, it has thousands of units. Okay? Actually, it is a polymer. Tinatawag nating polymer ng glucose. Tapos, meron din siyang mga glycosidic linkages doon. Okay? So for the next class of biomolecules, we have the proteins or polypeptides. So these are amino acids bound together through peptide bonds. So ano muna yung amino acid? So amino acids are like this. So meron tayong amino group, the carboxyl group, and the side chain. Tapos connected sila through the same carbon. So ang tawag dito ay alpha amino and alpha carboxyl. Okay? So this is an alpha amino acid. Okay? So pagka nag-react yung dalawang amino acid, nagkakaroon sila ng condensation reaction. So yung part na ito, yung amino ng isang amino acid at yung OH group ng isang amino acid, magpo-form sila ng peptide bond. Okay? So yung peptide bond na yan ay condensation product. So magre-release ng water yung reaction na to. Kasi yung isang H nito mawawala at yung OH na ito mawawala, magiging H2O, tapos magpo-form sila ng peptide bond. So this peptide bond is an amine. Okay? So these are the amino acids. So amino acids contain an alpha amino group, alpha carboxylic acid, and an organic side chain. So we have examples. Ito yung phenylalanine, ito yung side chain ng phenylalanine, side chain ng aspartic acid, and side chain ng lysine. So yung mga amino acids, pare-pareho lang sila ng amino and carboxyl group. Yung side chain lang yung nag-iiba. And yun yung ating identifying factor para sa mga amino acids. So we have at least 20 amino acids known. Okay? So pwede nyo makita yung mga amino acids na yan dun sa ating module or dun sa ating course guide. Okay? Sa mga literature din, nag-exist yung mga amino acids. Tapos classified na sila based dun sa nature ng kanilang side chain. Okay? So let's take a closer look sa mga peptides. So if we have a dipeptide, it means may dalawa kang amino acids. Okay? So may dalawa tayong identifiable na side chains. So that's aspartic acid and lysine. So ganyan yung name niya, aspartyl lysine. Tapos this dipeptide is connected through a single peptide bond. So kapag chain yung inyong polypeptide, kung meron kang N amino acids, okay, meron ka dapat N-1 peptide bonds. Okay? So yan ay pag-chain. Kapag ring yung inyong polypeptide, ibig sabihin, kung ilan yung amino acids doon, ganoon din karami yung inyong peptide bonds. So N amino acids equals N peptide bonds kapag ring yung inyong polypeptide. Pero kapag chain, N amino acids, N-1 peptide bonds. Okay? So for this polypeptide, makikita natin dito na meron tayong 1, 2, 3, and 4. Okay, na peptide bonds. This peptide bond is for the next residue, amino acid residue, as well as this one. Okay? So meron tayong 1, 2, 3, 4, 5 amino acids dyan na residues. Okay? Residue na siya kapag nakakonect na siya sa peptide. So, this is a polypeptide segment consisting of lysine, glutamic acid, valine, isoleucine, and asparagine. So, yun yung kanilang mga abbreviations. Pwede rin naman nating name ito using the single letter notation. So, yung lysine ay K, glutamic acid ay E, okay? So, yung valine ay V, yung isoleucine ay I, tapos yung asparagine ay N. So, that's a pentapeptide segment. Okay? So that's for multiple amino acids bonded by peptide bonds. Again, nasusunod yung N amino acids, N-1 peptide bonds. Pero in this segment, makikita natin na meron tayong mga extra na nilagay ko. That's for the next residue din. Okay? So, makikita rin natin na pwede tayong magkaroon ng amino acid polypeptide. Okay? Yung polypeptide chain na pare-pareho yung amino acid residue. So this is polyalanine kasi puro alanine yung ating mga amino acid residues. Okay? So, what are proteins? So, proteins are biologically active polypeptides. So, hindi basta-basta pwede nyo tawagin protein ang isang polypeptide. Dapat biologically active siya. So, dapat in its current form, nakakapag-perform siya ng biological function. Okay? So, kapag hindi siya biologically active, you cannot call that a protein. Or pwede mo siyang tawagin protein pero denatured siya. Hindi siya nakakapag-perform ng function niya dun sa biological system. Okay? So, proteins have the following structures. So yung primary structures, those are the amino acids bonded together through the peptide linkage. Okay? Yung secondary structure, kapag mahaba na kasi yung chain mo, nagkakaroon na ng parang intramolecular forces of attraction. So nagkakaroon ka na ng non-covalent interactions. So nagkakaroon ng IMFA yung inyong mga amino acid residues. So that's for the secondary structure. Yung tertiary structure, nagkakaroon na siya ng three-dimensional shape due to the long distance non-covalent interaction or yung IMFA. Nagkakaroon na siya ng ganong klase ng shape. Okay? So, that's due to the primary and secondary structures. Siyempre, nakadepende yun sa nature ng mga amino acid residues. Tapos, nakadepende rin yun sa interactions ng mga residues na yun. Okay? So, optional yung quaternary structure. Kasi ang ating protein pwedeng magkaroon ng more than one polypeptide chain or polypeptide unit. So, pwedeng isang single polypeptide chain lang yung protein mo, pwedeng maraming polypeptide units yung protein. So, this quaternary structure is due to the non-covalent interactions of separate polypeptides. Okay? So, nangyayari lang yan kapag ang inyong protein ay may more than one polypeptide unit. Okay? So, for another class of biomolecules, we have the nucleic acids. Okay? So, these are biomolecules containing a pentose sugar and a nitrogenous base, sometimes with an additional phosphate group. So, yung phosphate group na yun, important yun, lalo na kapag sa DNA and RNA structures. Okay? So, we have parts of the nucleic acid. So, una, yung ating sugar backbone, yung tinatawag. So that's the sugar, either a ribose or deoxyribose. So kapag ribose, okay, it's a pentose sugar. Kapag deoxyribose, pentose sugar din siya, tapos katulad siya ng ribose except for this part. So makikita nyo yung difference nila, OH sa ribose, H lang sa deoxyribose. So yung numbering ng ribose sugar, that's 1', 2', 3', 4', and 5'. Okay? So yung deoxyribose natin, pwede rin natin tawagin 2' deoxyribose. Okay? So for the next part of your nucleic acid, we have the nitrogenous base. So kapag purines, makita tayo ng dalawang ring structures. Okay? So yan yung mga purines natin, adenine and guanine. Kapag naman pyrimidine, isang ring structure lang. Okay? So we have cytosine, thymine, and uracil. So yung uracil, makikita natin to sa RNA but not in the DNA structure. Okay? So now, i-discuss naman natin kung paano nagko-connect yung mga parts ng ating nucleic acid. Okay? So, types of nucleic acids, we have the nucleoside. So, kapag nucleoside, nitrogenous base and sugar backbone. So, this is adenosine because this is adenine. Okay? This is the ribose. So, kapag deoxyribose, kapag H lang yan, ang tawag ay deoxyadenosine. So, dito naman, cytosine. Tapos, this is the sugar backbone, the ribose. This is cytidine. Kapag deoxy, ang ating ribose, that would be a deoxycytidine. Okay? So kapag nucleotide naman, meron na siyang phosphate group. So this will be adenosine 5' phosphate kasi sa 5' nakakonect yung ating phosphate group. Dito naman, this is cytosine. So this is cytidine 5' phosphate. So kapag deoxyribose, that would be a deoxyadenosine 5' phosphate and yung deoxycytidine 5' phosphate. Okay? So pwede rin tayo magkaroon ng triphosphate na nucleotide. So this is adenosine 5' triphosphate kasi tatlo yung ating phosphate group dun sa may 5' end ng ating sugar. Okay? Kapag this is deoxy, so that would be a deoxyadenosine 5' triphosphate. Okay? So paano nagko-connect yung ating mga nucleic acid residues sa DNA or RNA? So connected sila through this particular linkage. That's a phosphodiester linkage. So ang mangyayari, yung 5' end ng ating nucleic acid residue, ko-connect siya dun sa 3' end ng ating another nucleic acid residue. So that's a connection from 5' to 3'. This is a 5' to 3' phosphodiester linkage. So dito sa residue na to or dito sa nucleic acid structure na to, we have the 5' end and the 3' end. Okay? So 3' end to kasi ito ay 3', 5' end to kasi ito yung 5' na carbon ng ating mga backbone sugars. Okay? So ganyan sila nagko-connect sa DNA or RNA. So for the last class of biomolecules, we have lipids. So lipids are molecules with large nonpolar groups. So ito yung mga malalaking alkane groups or alkyl groups, okay? So tinatawag din natin silang hydrophobic groups. So hindi sila nag-interact with water because water is polar, yung mga alkyl groups natin ay basically nonpolar na. So they also have no distinct structural hierarchy like the other three biomolecules. Kasi kung mapapansin nyo dun sa tatlong biomolecules na na-discuss kanina, meron silang mga monomers, meron silang dimers, and polymers. So meron silang mga basic structural units. Tapos nagkakaroon lang sila ng mga linkages, okay, para mag-form sila ng mga larger molecules. So sa lipids, wala tayong masyadong gano'n. Okay? So distinct lang talaga ang mga molecules nito. So hindi sila nagpo-form ng mga polymers. Okay? So how do we classify lipids? So we have different classes. So for example, we have the hydrolyzable lipids. Okay? So the hydrolyzable lipids can be split by water in acidic or basic medium. So for example, we have the triacyl glycerol. So triacyl glycerol can be hydrolyzed to form the glycerol molecule plus 3 fatty acids. Kasi yung R1, R2, and R3 natin ay mga long chain na alkyl groups. So tinatawag silang long chain carboxylic acids or fatty acids. So yung mga long chain non-polar groups na to, ito yung mga tinatawag na hydrophobic tail. So kung meron kang tail, tapos meron kang hydrophilic head, yung hydrophilic head natin yung mga carboxylic acid groups. Okay? So, if the TAG solidifies at room temperature, ang tawag doon ay fat. Kapag yung TAG natin ay liquid pa rin, kapag room temperature, ang tawag doon ay oil. So, kapag yung inyong oil ay natutulog, kumbaga, parang natutulog na mantika, tinatawag natin siyang fat. Otherwise, oil. Okay? So, for TAG, meron tayong mga subtypes. So, for example, we have phosphatidic acid. So kapag phosphatidic acid, instead of 3 fatty acid residues, dalawa lang, tapos yung isa ay phosphate group. So ang example nito ay cephalin. So yung cephalin, instead of hydrogen, another modification is the CH2CH2NH3+. So this is a charged TAG subtype. Okay? So yung kanilang fatty acid residue, distinct din because cephalin is actually this molecule. Okay? So cephalin is not a class of molecules. Cephalin is this molecule itself. Okay? So for waxes, okay, kapag waxes naman, they are long chain esters. So yung R2 and R1, they are long alkyl chains. So mahabang chains yan, R1 and R2. So ganun din yung phospholipids. Yung R1 na to ay sobrang haba. Okay? So those are the hydrolyzable lipids. So then we have the non-hydrolyzable lipids. So non-hydrolyzable kasi hindi sila may split ng water. So for example, we have steroids. So steroids has this unique, okay, core structure na madaling ma-identify. So kapag nakita niyo yung structure na yan, it's a steroid. So for example, we have cholesterol and testosterone. So for eicosanoid, mas mahirap ma-identify mga eicosanoids because they have different core structures. Pero ang identifying factor dito is that they have 20 carbons. Okay? So, eicosanoids kasi sila. So, the eicosanoid means eicosa. Okay? That's 20. So, prostaglandin is an example. Okay? So, signaling molecules sila. Natitrigger sila ng mga biochemical processes. Okay? So, finally, we have the terpenoid. So, terpenoids are repeating structures of the so-called isoprene. So, yung isoprene ay, okay, ganyan. Yan. Ganyan ang itsura ng isoprene. So, nagre-repeat lang yung isoprene units na to form the terpenoid. So, for example, we have the lycopene. So, kung mapapansin nyo, meron siyang repeating structures of this type. Okay? So, yan ay isang klase ng polyterpenoid, yung lycopene. Okay? So, yung lycopene and other beta-carotenes, okay, yung mga ganitong klase ng molecules, meron silang mga distinct colors. Okay? So, sila ay mga components ng ating mga fruits and vegetables. Okay? So, this is my discussion on the introduction to organic chemistry, functional groups, and different biomolecules. So, ang susunod kong topic ay IMFA or intermolecular forces of attraction. So, see you next video.